Welcome to the next session on basic linear algebra, where we talk about matrices and special form of matrices. A matrix is a rectangular array of numbers or a collection of vectors. So in the last video you have seen a vector of the dimension m cross 1. A matrix here, the matrix A, is just several vectors written next to each other. And again, a matrix has a dimension. Here it's m cross n, the dimension. And the number of, or the m gives you the number of rows in this matrix, and the number of n is the number of columns, or the value of n is the number of columns you have in this matrix. So here you have this regular A matrix of the elements A11, A12, A21, and so on overall. And matrices have special names depending on how they look. And I want to show you a few of them, which we will dive into later when we go into network theory or input-output modeling, where it's really important to just know some features and what they do with that. And so the first one I want to introduce you to is a square matrix. Fun thing is pretty much it is a square. It has exactly the same number of rows and columns. And the next one is a symmetric matrix where the element on the diagonals are different, but the across the diagonal, so here the element S11, S12 and S21 would be exactly having the same value. And so you have on each on the triangulars of the matrix, apart from the diagonal, you have exactly the same values. And a rectangular matrix is of the size m cross n, where m and n are not equal. Well, again, it's same idea as the squared matrix. It gives you just that by the name, it's a rectangular and it's not a quadratic form. And in the same spirit, we name something and it's exactly what it should be. Zero matrix, you have a matrix which consists of exactly only zero values. It's not an empty matrix, it has zeros in it. An identity matrix is something really, really important we will use later in matrix calculations. It's pretty much an identity and zero matrix, but on the diagonal you only have ones. And the rest is zeros. It's really important later on in doing math with matrices. And diagonal matrix is pretty much identity matrix scaled by a different value. So it's not everywhere the same scale, but you only have values on the diagonal. They can be different. D1 can be different from D2 and Dn, but it's really important you only have values on the diagonal and the rest of the matrix are zeros. An upper triangular matrix is another case where the matrix does exactly what the name is telling you. You only have in the upper triangular, so everything on the diagonal and above is consisting of values, while the rest under this diagonal are filled with zeros. And again, a zero is a value technically, but keep that in mind that here the zeros are always under the diagonal, not ruling out having zeros also in other places, but it's a really special case that you want to keep in mind. We have also lower triangular matrix, which is exactly the same thing as the upper triangular, with the difference that we have the values only on the diagonal and below.